All right, so welcome everyone. Yeah, we'll kick off. So very excited to have Brent Mitchell here today from Redcastle Resources. So I'll hand over to you, Brent, and feel free to get started and give us a good background.
Hey, thanks so much, Nathaniel. And hi, everyone. I'm Brent Mitchell. Nice to meet you all virtually. I'm with Redcastle Resources. We're a small business. We were founded in 1998, and we've been focused on geospatial technology since then. So I kind of say we've grown up with geospatial, and some of you might remember in the early 2000s, processing, Landsat imagery was cumbersome and it took a long time. And so we've come a long way from there, and now we're in a very interesting and new time. So we're going to kind of focus on that today. A little bit about myself. I got an undergraduate in biology, and I actually did my master's at University of New South Wales there in Sydney. So I got to enjoy beautiful Sydney. My wife's actually from Sydney, so I appreciate all of you, and I appreciate Australia. So anyway, with that, today, what do we want to talk about? GeoAI made easy. Exploring Australia's changing landscape with ASKTERRA's conversational AI. So I want to take a little bit, about 4 or 5 slides, just to talk about general concepts that we think are important in geospatial right now, and with AI coming into the picture. And then I think we'll spend most of the time on a live demo so that you can understand how we're integrating geospatial foundational knowledge with the current influx of AI technology into many different fields. And please, during the presentation slides and or demo, please feel free to speak up or ask questions and interrupt me. We can keep this very casual from my perspective. Okay, well, with that, can everybody hear me and see everything okay? Okay, great. Well, let's jump right in. So I kind of like to start here. I kind of mentioned this earlier, but where are we on the timeline? And so some of you might be geospatial, some of you might be remote sensing experts, and maybe some of you are just know a little bit about geospatial. I won't assume anything, but one of the things that's interesting to me right now is just to step back in time and look at the Earth observation timeline, this is the most recent snippet. In 2008, we started to get free democratized satellite imagery for the globe. So the Landsat archive from the US was made public. Everyone could download it. It used to be a little cumbersome. They send you a DVD or something, or you download it, and it would take forever, right? Some of you might remember that. But we had the data. We were able to get global data. Then 2010, Google Earth Engine was launched, and that's when we started to see the cloud being used much more, right? So Google Earth Engine took the entire Landsat archive, put it in the cloud, and made it accessible to all of us, right? And then we started using APIs and writing scripts. We didn't have to store data. We didn't have to, we could send our commands into the storage, do the analysis, and get the results out, right? So that's when we kind of got into this cloud type remote sensing environment where we got a lot faster. We had a lot less pressure on us to manage all of the data, et cetera. Then we added in the Sentinel archive. So now we've got multiple sensors in Earth Engine. We're imaging the globe every 3 days with Sentinel, basically. And now here at 2025, we've got the AI integration. So we're all hearing lots about AI and advantages and disadvantages and fears and hopes and all the things. And where we are with it right now, from our perspective, is that we're kind of in a GeoAI era. And this statement, I think, captures how we're thinking about it. Natural language interfaces that allow users to query the entire planet, right? So when you think about that statement, it's pretty interesting time to be in geospatial. So we're trying to make that happen, and that's what I want to share with you today. So this is probably something all of you know, but I think it's a good reminder to kind of justify and explain where we're trying to go with our tool, ASKTERRA. So a lot of you probably write a lot of code. If you don't write a lot of code, you work with people who write a lot of code, right? So the folks in our industry get familiar with that, and it gets complicated. But we get familiar, we get adept, and we're very efficient at that. You combine all that coding that we do with the Google environment. Let's use Earth Engine as an example. There's an infrastructure. There's these very, very flexible APIs that let you take that Python code or JavaScript code, send those queries into the cloud like we talked about, do a lot of analysis, and get these really nice outputs back. And that leads me over here to the GUIs and the outputs that we're all probably creating or at least using, right? As a geospatial community, We want to make the data accessible. We want to make it interactive. But as many of you probably know, as easy as we try to make it and as interactive as we try to make it, there's still a barrier to folks, right? They don't feel like they own the data. They aren't engaged with the data necessarily. And they're a little hesitant to really dive into some of these interfaces. So that's at least our experience. So we spend a lot of time on these dashboards and web maps, but we still feel like they're not being used how they could be, and people aren't engaging with that data. We think there's a lot more that could be done there. So we kind of looked at this sort of evolution of geospatial, and we kind of categorized it in two pieces. The geospatial foundation of all the cool things we do, right? The code and the APIs and the cloud. And then there's these outputs. Can we make the outputs faster, simpler, and more engaging for more people so that more people see the value in geospatial? So that's where we're kind of coming from this at. And our solution to all of this is a new product called ASKTERRA. And essentially, it's a conversational GeoAI platform that allows everyone through natural language to explore the changes on the globe, right? And so that people can come up with a good question. They don't need to know how to write code. They don't need to know how to navigate the code editor and Earth Engine. They just need to have an intelligent question that they can ask in a chat prompt. And when we started doing this, we thought, well, let's not try to do everything, because if you think about this sort of structure, it's limitless. But we wanted to focus on a couple of things that we do really well and try to get this tool to be robust and solid and not give weird answers and do the thing we want it to do. So we focused on two things: near real-time change detection using the Landsat and Sentinel archive, right? So 1984 to basically 3 days ago, the last time Sentinel passed over when there weren't clouds. That's essentially our time frame, right? So near real time. And then the other thing we wanted to do is we're leveraging Google DeepMind's Weather Next forecasting model. So essentially their climate weather forecasting models, they go 10 days into the future. And so they're touted as being, I think a lot of models are accurate up to 3 days. These are touted to be more accurate for a little bit longer. So the idea with these, with this weather prediction is that we can create risk models for tree damage, for flood, for fire risk, and we can push that 10 days into the future. So if a cyclone's approaching, if there's some bad weather for fire danger, we're hoping that we can create some models that a lot of people can access those and look 10 days in the future and say, oh, we need to be on high alert for fire danger. We need to be thinking about damage that might come. The question, Dula?
Does it work hand in hand, can it work with the Flood API?
With the which API?
Flood API, Google's Flood API.
Right now it doesn't, but it could. The whole infrastructure can hit an API, right? But good question. Right now it's just the Earth Engine API.
Okay, thanks.
Yeah, but this whole idea, yeah, right. It's limitless, right? Any API with a good code structure that you have, you could sort of recreate that. Great question. So again, we focused on a couple things, but you're right. It's endless, and that's where we're kind of excited too, is we see this as just the beginning. So kind of want to talk about like why do this? What's the value proposition for different types of users? So the first one is the non-remote sensing experts, and that doesn't mean they're not geospatial. That just means maybe they're not used to writing JavaScript or Python to hit APIs to pull change detection data, do analysis, right? Or it's people who aren't geospatial, right? So we think that this approach can save a lot of time, right? So you don't have to do all the heavy lifting. This does all the heavy lifting for you in the background. And then the big thing is access. So not only do folks like us who write scripts can access this data now, it's field technicians. It's geospatial folks that don't have time to learn how to do that. It's also executives or decision makers or compliance officers, people who want to see what's changing on the landscape, but are pushed back by those barriers of coding and Google infrastructure, et cetera, et cetera. The other thing that we see with this that's exciting is the collaboration piece, where a lot of people can start looking at this geospatial data and they can do it together, they can interact with it together, and then they can share it back and forth in a really easy, nice way. And I'll illustrate all that in the demo. And then last but not least, a lot of you probably been involved with new technology comes out. And, I remember when I was teaching people about LiDAR in 2005. We had a lot of people who were getting LiDAR data, but they just weren't using it, right? It was sitting on hard drives and desks. Probably, a lot of you have probably experienced this. And when we would train them and we would integrate them with the data and show them how to work with the data and get results, then their confidence really grew. And then they really started sharing that with other colleagues and using in their workflows. So these are all the benefits we see. Now you might be asking, well, hey, I can write code. I don't need some GeoAI to help me do change detection. Like, I already can do that. Why do I care about this? Well, I think there's a few reasons. The first is accessibility engagement. That's kind of the last slide. We already talked about that, right? Increasing demand and feedback. So we feel like this tool, if we get more people engaged with this data, we're going to get a lot more feedback. We're going to get a lot more demand for the types of things that we all do. And from that, we think there's going to be a lot more code that needs to be written. There's going to be a lot of SMEs and other fields that maybe touch this, something like this, and get engaged with the data, and they start asking questions that we're not even thinking about. But then they need people like us to write all of that code underneath the hood to answer those questions. So that's kind of where we see this going. And then ultimately just expands the community. Is there risk, right? There's lots of risk with AI. I think at the moment with where AI stands now, it augments our workflows. It doesn't take away our jobs as far as we can see it. It augments what we do and makes it more accessible to more people, and hopefully grows our community. Okay, so let's jump into the demo, the fun stuff. Let's see, and we're going to do a live demo, so wish me luck. Hope it all goes good. So this is our interface, right? So it's kind of like a chat interface. But it is geospatial, right? So we wanted to have a base map present so that when people open this, they realize, okay, I can chat to this chatbot, if you will, but it's not just, I can't ask it how to make chocolate cake. I need to ask it geospatial questions, change detection, and weather forecasting. So just a few, the components. We've got this base map here. We can navigate all around the globe. We've got the conversational panel on the left. We've got some example conversations that people can start with if they're not sure how to use the tool. But you can also down here actually type in whatever question you want about change detection or weather forecasting. So this is kind of how it works. We also have some options to choose the different models. We found that right now Perplexity, which uses Gemini and a few other LLMs in the background, also does a really nice web search. So people are able to query current events. And they're not limited to the knowledge foundation of those LLMs. They actually can search for current events and make sure that everything's included. So that's why we've chosen that at this point. That could change. Okay, so we can explore more of the tools, but let's actually do a query. So for now, instead of typing one, I'm just going to pick one of these. So many of you are probably familiar. I think it's called Black Summer, the 2019-2020 Australian bushfires near Sydney. And so map the 2019-2020 Australian bushfires near Sydney, right? I could have typed that, but I chose one that's here. We click the run button there. That prompt gets sent out, and ASKTERRA does its magic. So, and we're going to see exactly why it's not magic and how we can interact with it. So it's still kind of loading. So everything that's happening right now, this is all streaming live from Earth Engine. So that query sent our scripts into Earth Engine through the API, did this analysis, and kicked it back here. So all this is being done live on the fly. So we can see also, you'll notice that it only maps a certain, I'll zoom way out so we can see. So at this point, we put a governor on how big an area you can analyze, because when you run a query, right, you get charged for the LLM, and you get charged for Earth Engine. So we don't want people to just make mistakes and burn a bunch of cash because they think, oh, I'm just going to do this analysis on all of Australia. You can do that, but you just need to know that how much it costs. And we'll go through how we can look at the cost here in a moment. So here is the change detection. We can go into the map itself. We can look at the layers that were used. So we have this difference layer, right? So we're looking at differences on the landscape being mapped. So the nice thing about ASKTERRA is not only does it give you a change product, but it gives you the raw data that was used to do that. So we can see that we've got a composite from July and August of 2019. So pre-fire. So now we're going to load, I'm going to zoom in a little bit. So now we're going to load that. So we've got Sentinel Cloud-Free Composite from July and August of 2019. And now we have the post-event from July and August of 2020. And we can see those burn scars. And then if we zoom in and look at some areas, we can turn on that change again and kind of validate on our map, is the change getting mapped how we want? So, right, we've got all 3 layers from the analysis. Now to pull your attention over here to the conversational panel, we can see our question, right? And remember, it's a geospatial AI, right? So we need a time, we need a place, and we need a change. So when I just said, you know, map the 2019-2020 Australian bushfires near Sydney, use all that information to make sure that we're honed in on the right location and we're doing the right change detection for the right pre and post images. So in this conversation, we can see that all happened in 11.3 seconds. And you can see our charges against the LLM and Earth Engine. And then it gives you a little bit of context, what the map covers, some sort of reference from the bushfire, talks about some of the places. Now it gets into the sort of computation that it did, the pre-fire composite. When did it pull that from? The post-fire composite. When did it pull that from? So you know when that is. It tells you what index it used for the change detection, the normalized burn ratio, right? So it knows because you are mapping fires, we've trained it to say they want to map fire damage, it's NBR. They want to map vegetation change, it's NDVI. So it has a few indexes available to it. There's any of them that can be added, right? That's using Landsat or Sentinel. So there's no limitation there. But at the moment, we focused on 2 or 3 of them. It also gives you an interpretation of the map, how to interpret the red areas, how to interpret the blue areas. And then it also gives you a confidence level based on your question and what it found and what it produced. It's got high confidence that the region, the dates, and the index are well supported by this data and the area that we're looking at. And the other thing it does is it gives you some citations from the internet that you could check to validate, hey, is all the things I'm seeing from the question that I asked, do they make sense? Are they supported by other references on the internet? So that's the conversational panel. Now, the other thing you might be asking is like, oh, am I stuck with these dates? Am I stuck with this threshold? No, you can ask ASKTERRA to change the dates for the pre and post imagery. You can ask it to change the index or the sensitivity of the threshold of the index. So you're not locked into what it does initially, it just gets you started. And then you can continue to interact. So I might say, well, when I'm looking at Katoomba here, I see the change and I think, well, let me zoom in here. I don't know, this might just be seasonal dry vegetation, right? Maybe one season's a little drier than the other. Is that actually a fire scar? So maybe I could say to ASKTERRA, can you make the threshold less sensitive to change? I could specify what I want the threshold to be, or I could just say, hey, can you make it less sensitive? Either way, you could give it a negative 0.002, or you can ask it to change it. So either way, you have complete control. So now it's gone ahead and changed the threshold and rerun the analysis for us. And maybe we think, okay, well, now I'm looking at Katoomba and maybe this stuff here that's maybe just a little drier the year before or a little drier the year after, it's a seasonal change. It's a drought change. It's not a fire scar, right? So I've been able to tweak my analysis and refine it a little bit. So the idea here is that you have complete control of the algorithms that are doing the change for you. Now, there's a couple other tools here that you can use over on this side. We've got a bunch of different base maps you can use. We've got some simple measurement tools, distance, area, and we've also got some other really interesting things that we put in there for communication. So maybe you're working with someone who's trying to rehab stuff up near Katoomba. They want to know where that fire scar is. They want to look at that. Maybe they're not a GIS person. And you think, well, hey, I want to share this with them. So we've got a feature here where you can just create a simple PDF report that quantifies the area that's been changed. It gives them the image, the post image, and the change. And it gives you a little histogram about how much of the area has changed. Come on. Hopefully it'll pop right up here in just a moment. It's taking a while, of course. There it is. So then you can see you've got this really nice PDF report. Now this is a simple version that's not catered to any use case, but in the future, we're hoping to collaborate with clients and say, hey, what is the type of report that your folks need that you could create for them really quickly and just send to them. They don't need to open a geospatial software. They don't even need to know about it. They get this informational package. We can include any text that we want. We can include the different images so they see what's going on. We have the histogram of change on the ground. So just an informative, easy way to share some of this geospatial data. And the other thing that we can do is we can download thumbnail images, PNGs, but even better is we can download GeoTIFFs. And so if you say, okay, I want to do my initial analysis here, but maybe I want to download this data. I got cloud-free composites. Maybe I want to do something else with them. I want to do my own NBR change map. I want to do it in my own GIS. I want to put it in Python or R. No problem. Download the GeoTIFFs and do whatever you want. The other thing you can do is export these into, or push them into as tile services and ingest them into your GIS. And one other way to share is this little feature here, which I think is really cool. So if you're an ASKTERRA user and you're working with other people who are using ASKTERRA, you can just copy this link and send that to them, and send them the URL. And then if they're an ASKTERRA user, they log in, they takes them right to your analysis. So they have your conversational history on the left here, so they can see what your initial query was. They can see what the conversational answer from ASKTERRA was, all the information about the change detection that was performed. Then they can see that, oh, he refined he wanted to make the threshold less sensitive. He wasn't very specific, but okay. So then you've got an explanation of what change was made to the analysis. And then they've got this, they can interact, they can continue with the analysis. So they can continue to refine it, or they can collaborate back and forth with you. So we see this as a really nice tool, not only for collaboration between multiple geospatial folks, but for education also, like learning with other people, collaborating, share. Hi, Ian, you had a question. Does that use their credits? Yeah, so if they open the map, it will load the map and use their credits. It won't use their LLM credits because they're not running the queries. But when they stream that live data into their instance of ASKTERRA, it will ping their credits. So we tried to, and I'll show you how you can monitor that. And well, maybe I'll do that right now. So that's a great question. And what we want this to be is very transparent to all of the users. We don't want you to feel like you're doing stuff and all of a sudden we say, oh, you're out of credits, got to buy more credits. So we've made it very easy for everyone to monitor their credits. So we've got a dashboard here. You can pick the time period. So let's do the last 7 days, apply the filter. So it tells me how many large language model credits I've used, how many Earth Engine credits I've used, what are my total CDUs. It charts them out for me. You can see that here they are over the time that I'm using them. You've got the different LLM models that you're using. So it's telling you which one's burning more, what you're using more. It also breaks down the Earth Engine, different work types, right? So you're downloading tile services, composites, 2-date change. I've done some weather stuff, so you can see that here in something I did earlier today. So it tracks everything you do and it breaks down your costs of all the queries that you're doing. So what's nice about this is we're excited to be able to understand all the things people are doing and then what's costing more, what's costing less. And it's a really nice way of, a lot of times I know people have complained about Earth Engine. It's so hard to know, like, how much does it cost? Like, am I going to get a big bill? With this is real-time monitoring. So every time you do something, we query Google Cloud and we get how much you're getting charged back and you can monitor it in real time. So that's a really nice feature. We also have all the chats. We have your different downloads. So lots of nice things there. The other piece to monitor is your cost estimation. So this is another really cool thing where you can look at different users, how much cost, what are the typical costs for different queries, what are kind of max daily, average daily, median, the LLM costs, and LM model usage distribution, so different ones here. So lots of information that allow you to understand how you're spending your credits when you're using ASKTERRA. So good question. So I've shown you some of the features. Are there any questions at this point before I show a few more examples? Okay, well, interrupt at any time, please. So I just wanted to show some other things that it can map. So, and show, kind of type those in. Last time we picked one, but this time let's type one in. So let's map flood damage in Hunter Valley, Wales from 2025, right? So I know there was an event. I know there was a flood. I don't know exactly what date it was. I know the general area. So let's see how ASKTERRA deals with that. And then maybe, so there's sort of an area near the Hunter Valley. We see Maitland there. So this map covers the Hunter Valley, New South Wales. So we did a pre-flood composite April 10th through May 10th, and then a post-May 20th to June 10th. We use the NBR because that's really sensitive to moisture changes. Again, it gives us the threshold. It tells us how to interpret the map, and it gives us a confidence level, right? So let's kind of zoom in here and figure out what's going on. So let's zoom into this area. It's pretty active. And we're seeing a lot of loss of moisture. I'm assuming that's going to be vegetation damage from the flood. So let's just expect that really quickly. So let's look at the pre-flood imagery, right? We see this healthy agricultural area. Then we turn on the post-flood imagery, and we can see all of that. This is probably basically after a lot of the water has drained that flooded, and all that vegetation has been killed or damaged. So we're able to map the damage from the flood, and then that kind of tracks right there. We can see. Now we can see that some of these reservoirs over here seem to have gotten bigger. So let's look at that. So we look pre, and then we still have standing water in those areas after the flood here, here, here. So we're picking up all those changes. Now, potentially we might think, well, I want to maybe do that post date a little earlier so that I can see standing water in other places. So potentially you could change the dates. So I can say use a, let's see, we did April, when was the May 2025? So May 20th to June 10th. So maybe we want to do May 15th to June 5th. June 5th for post imagery. So maybe we can get a little more standing water in some areas potentially. The other thing we have to think about is cloud coverage, right? If there's still a lot of clouds, we might not get the data that we want. So that worked. We can actually see, okay, we tweaked the date range. Now we can actually see some more standing water. Let's turn that off. I think that's going to become pretty obvious pretty quickly. There's our pre-cloud free composite. There's our post event. There's all that standing water. So we tweak the dates to hone in if we want to see where standing water is or we want to see where dead vegetation is. So again, you just have complete control of how you want to use. And so instead of editing scripts, you're able to ask. So the idea is that for people who don't feel comfortable editing scripts and rerunning analysis, they can refine their question. And so we kind of get into this prompt engineering workflow where people get smarter and smarter about the questions that they ask to hone in on what they want. So obviously, you have to have some geospatial awareness to ask smarter and smarter questions, but we're hoping this will accelerate the way that people ask geospatial questions and they start to understand, hey, there's cloud cover, there's the timing scenarios based on what change we see. You can do voice input. You can hit the microphone and ask it for whatever you want. And the other thing I'll mention is you can type questions in any language. So this is global. Anyone can use it. It doesn't need to be translated or anything like that. So
there was another question in the chat there.
Oh, thanks.
Can you get the Google Earth Engine script for reproducibility?
No, not at this point. That could be something that's a great question. I mean, maybe that's something we can think about in the future. That might be a nice feature. What was the other question? I just missed it. Something else popped in there. Is there another chat? Can you use this? Ask for a specific name if you know it as a site. Yeah. So I could say do the analysis with NDVI. So yes, you can request. I think right now we have NBR, NDVI, NDSI, which is a snow index for mapping receding glaciers or snowpack on the landscape. So right now we have those 3 indexes that are available, but again, we'd love to hear your feedback. If there's other indexes that you want to use with Landsat and Sentinel that you think would be really useful, please share those with me. It's really easy for us to integrate those. That's not hard at all. And the part of this is we really want to make sure that we collaborate with all of you. Where do we want to niche this, right? So this is the base product. We'd be interested in collaborating with folks and say, well, we'd really like to see this. And our coders would be super excited to say, okay, yeah, let's make this custom version of ASKTERRA for this usage group. So yeah, great questions. Let's see, other questions. Do you have an example of ASKTERRA in commercial production? No, this is the beta version. It will be going commercial. I keep saying soon. I think next week it will be commercial. So it will be available to all of you. And I could talk about that briefly at the end. We want to make it, we want to do a soft release commercially and give a very, very low cost entry so that lots of you folks can get in there, start using it and give us some feedback. And we'll do kind of a soft release special on and make it cheap. So right now, no, it's not commercial. Okay, does the platform support the classification algorithm implemented in Earth Engine classifier for prediction? No. So right now, it does not do any classification. It's only 2-date change detection. So that could be version 2, version 3. We're not doing any classification. We're not saying why the change occurred. We kind of have some idea why the change occurred, and we can be somewhat confident that we're mapping a fire scar, right? But we don't know for sure. So if we know in that 2020 case with all those fires around Sydney, I mean, based on all the evidence, we can be highly confident that we're mapping fire scars. But in this case, right, there's change up here that, is that we're seeing stuff along the river. We see agricultural change. So it's going to map any change when you ask it to do this for this entire landscape. So it's not classifying the change. It's not giving you the magnitude of the change necessarily. It can give you a little bit of the magnitude of the change, but it's hopefully that answered your question.
Brent, could I ask a question?
Of course.
It's a great work you've done here. I think it's fantastic.
Oh, thank you.
I think that question about getting the Earth Engine script is really something worth thinking about. I don't know if it's a technical or a product decision, but
Yeah.
the thing is a lot of this will be used in contestable situations,
Right.
where you go, I reckon this fire caused air pollution, and and then somebody else might say, well, no, we disagree with you, show us your evidence.
Right.
And I can say, well, my chatbot told me.
Yeah, right, fair enough. Yeah.
So if I had an opportunity, my first question would be, as a follow-up to this question, to the chatbot, is can you do what you just did and export the Earth Engine script?
Okay. And if you asked it that right now, hopefully it would not let you do that. But I see your point. That's a really good point. I think
I'll let you try that. But like essentially, think of it as exporting a scientific paper.
right.
Like you've got to be able to back it up with data, and data scientists know, if they're scientists, they're good at stats, and there's a lot of ways you can use stats and misuse stats.
Yep, totally.
And I'm not sure how good the chatbots are yet at those. It's more of an art than anything else to do stats right. And so I think that's an area to really delve into.
Yeah, that's a really good point, Chris. I haven't thought about that. No one said that, but you're right. And I think, and for us, right, there's no, the proprietary part of it isn't the Earth Engine scripts, right? That part is open source on the Earth Engine forum, right? We're not using anything magical there. So I can't see that being a roadblock for us. And I think maybe you're right. That's a really great feature where people can say, okay, not only did I get here fast, but now I can export what was the script for the map that I really want to share, and I can show you that it's driven from this data in Earth Engine, and here's the proof that you could replicate this.
Yeah. And sometimes you might review it and say, oh, look, I can see where you're going wrong here, and feed that back. And then it will fix those issues if you know, if you're competent enough to review the script. And the other thing I'd like to see is combining data. So like not just taking one data source, but you know, combining air pollution data with fire and flood or something like that.
Yeah, and that's a
great.
Yeah, great point, Chris. And that's something where, you know, we want to, there's a lot of data sets out there, right? And right now we're kind of leveraging Earth Engine. So basically, right, as at this point in this product, anything that's on Earth Engine in theory, we can pull through here. So we just have to figure out, like, okay, if there's like air pollution data associated with these fires, how do we train ASKTERRA to know, okay, what are the types of questions people might want to ask about that? And then how can we, you know, hit that API and pull that data? So really good point. So yeah, I'd love to chat more about that stuff, the air pollution. And I don't know, I'm sorry, I don't know what data is in Earth Engine, but I also know that people can upload their own data to Earth Engine too. So that might be a nice way. If there was data, and that could be you know, you could have a private instance of ASKTERRA with your data in there integrated with all these other things that Earth Engine already holds. So lots of opportunities there, but yeah, great points. Thanks for that feedback.
Lots of features. Good luck.
Yeah, I know. And like my PI says, this is limitless. We got to just focus to start. But we're excited that there are so many opportunities to add more things. So yeah, great insight. Okay. Thanks, Chris. Any other questions?
There's a couple in the chat there. Wait, I'm just going back. Resolution of the data.
So it's 10 meter, basically it's Sentinel or Landsat. If you go back far enough, it's going to be 30 meter sample down to 10. But from 2017 to now, it's all 10 meter Sentinel. So 10 meter resolution.
And raw bands or just indices?
Generally indices we're throwing. I mean, well, you do have, you know, you do have the cloud-free composites that are displayed. So you have them, and you can export these cloud-free composites. So you can have the raw data in a GeoTIFF format if you want. So you have that. You have the pre, you have the post. You can export those as GeoTIFFs, and then you've got the change layer. So all that's available. And so, you know, we go and get it from Earth Engine. And if you want to export it, you can export it out as a GeoTIFF and then do whatever you want with it. You don't have to stay in ASKTERRA or Earth Engine.
Good stuff. And was there a follow-up to that one? And I had a question, just that, but it's another feature, I guess, request. I'll post it in the chat. Is there any integration with the geospatial reasoning platform? Plans for that? Yeah,
we've been talking to those guys at Google. So yeah, kind of like, yeah, so not yet, but we'd love to. And they've been interested. So we've been kind of chatting back and forth, and where are they going? You know, we were thinking about, you know, all the census data, buildings, all the population, human geography.
As you said, it's limitless. So.
It's exactly. Yeah. So that makes it so exciting. I know I keep pushing my PI to just finish this so we can go. Then let's talk about versions, you know, 2 through 50. So he's getting distracted also by all these cool things we could do. So 10-day projection, absolutely. So Matt just asked if we could demo the 10-day projection. So let's do that. So let's say forecast the max wind speed on the eastern coast of Australia for the next 10 days. So the idea with this is that we want to wrap all of these risk models around this prediction so we can forecast into the future 10 days. So the idea is that that's really valuable, right? For fire risk, for flood risk, for wind damage risk. And so it focuses on the region. These are a little bit more coarse. I want to say that they're 250 meters, so it is more coarse. Can the model use the Alpha Earth foundations? The embeddings. Yeah, in theory, yes, we can use the embeddings. We just haven't gotten there yet. But that's in Earth Engine, and we're working with Google right now, looking at higher temporal resolutions of the embeddings. And so we're doing some study with them just to explore, like, could we get embeddings every month? Should we get embeddings every 2 weeks? Would we request embeddings for an actual disaster event? So if a hurricane or a cyclone occurred, could we get embeddings pre and post? And would that help us classify the magnitude of the damage, like what was there before and what it, what's the magnitude, what did it change, etc. So great questions. So here we have that 10-day into the future. We can just zoom right out because these are kind of nice at scale, the bigger scale. So right here we've got, we're displaying the max wind. So no cyclones approaching. We got the roaring 40s down there, right? So we also have, not only do we have the max wind, we have the other thing I'll show you right now, it's not calibrated for Australia at all, but for the United States, we have what we call the WeatherNext Gales damage model. So this is our tree blowdown prediction. And I think based on the, based on the weather that we're seeing here, because the wind out here in New Zealand, your little neighbor, you can see that there's some relatively, high winds along the coast there. There's trees there. Now, again, it's not calibrated for New Zealand, but in the southeast, if these trees were this tall, and they were, we have species data, so it's kind of confused, but we can say, 10 days into the future, if there's a hurricane approaching North Carolina, there's lots of forested land, there's lots of, neighborhoods, there's lots of cities with lots of trees. We can have some confidence in predicting 10 days out what trees might blow over. So we use wind speed, we use the type of tree, we use the height of tree, we use the modulus of rupture, which is like a test of, like, if a loblolly pine tree is 100 feet tall and the wind is 100 miles an hour, it'll snap. And so there's this algorithm that we're using to do that. So we're trying to refine that and get better at that. So that's the kind of thing we're hoping to use these forecasts for, and obviously flood and fire modeling. The other thing that's in here is precip, right? So cumulative precipitation. So you can see, the usual rainy places, New Zealand, Tasmania. But this is a really cool global too. You can zoom out on this and see the next 10 days of precip around the globe. If you come back over here, you can see our current cyclone or hurricane season. The storms spin off of the Sahara. They come across and ram into the United States. That's our pattern. So you can see there's a few things going on here. If we turn on that max wind again, you can see that, let's see if it's gonna load. Let's turn that off. Precip, turn that off. We've got the wind. So we've got some action. We've got a few little things spinning off here. So we've got a pretty active Atlantic at the moment with our hurricane season. And then last but not least, we get temperature. So that could be helpful certainly for fires and et cetera, et cetera. So just kind of looking at that at a global scale also. So these are the 10-day forecasts. And again, we built that tree blowdown model around that. And we got the max wind speed, predicting hurricanes 10 days or cyclones 10 days in the future. Google showed that with that WeatherNext model, they were much more accurate during the 2024 season than a lot of the other weather models. So that was one of the demos that Google provided to us about their WeatherNext model. Predicting hurricane tracks seemed to be validated by where those hurricanes made landfall. So that's promising, and so that we're using that. So great questions. I've got more examples, but I'm also happy to do more questions to whatever you all want to do. Is there anything someone wanted to just randomly query? We could try and do some change if there's a topic someone's interested in. I've got examples, but also it'd be great to kind of to see if we can break it. It's always fun. Well, while y'all are thinking about that, let me show you one more thing. One thing that we can also do is we can, you might be thinking, well, I don't always want to query. Maybe I know there's a location that I'm interested in, and it's going to be hard for me to query to get to that location. So we understand that as a geospatial person, you might not, there might be some random spot that we can't write a query to get there. So we've also created this little guy here. And so as I start to scroll, it gives coordinates for the map. And maybe let's say I'm interested, maybe I think this might be wheat. So maybe I'm interested in monitoring an agricultural area, right? So I could say, I zoom into this area that I know that I'm interested in. We also have, okay, yep, no, not yet. So I zoom into this area that I'm interested in, then I can say, what change do I want to see? So I don't have to query to get to the location. I can just zoom to it. Then I can say map, agricultural, health, or change from June to July of 2025, right? So it's going to compare June and July for this area. Is it greening up? Is it being irrigated? Is it declining? Is it being harvested? So again, you can look at this area. We can go in. We can turn on the pre-image Sentinel data, right? Okay, this is in June. This is the area we're looking at. Then come July, we've got a ton more irrigation or rain or whatever it is. Things are growing, right? And so if you're monitoring agriculture, you could look at, every 2 weeks, compare last year to this year, compare last month to this month. So you can change the dates and you can monitor, for food security, for what's the yield going to be. So we see a lot of application here, and we've been talking to some different agricultural companies that are interested. And I don't know, I think this is really interesting. So a nice way for folks that monitor their agricultural assets, understand what's going on. How does it compare to last year? Is it better? Is it worse? Or is it stressed? So there's lots of things you can do there. So anyway, the point there was you can navigate to anywhere on the globe. You don't have to always query to get there, and then you can do your change. So we want to make sure that geospatial people who know where they want to go can go there. They don't have to be frustrated trying to query to get there, kind of thing. So more questions? Let's see. Use how many data sets does it support? Can you choose the data set and through the prompt? No, you can't choose the data set. Right now, it uses Sentinel or Landsat. And so if it's more recent, it'll use Sentinel. Sometimes if there's too many clouds, you'll get a gappy result. So you have to change your dates to try to work with, if you're trying to map a flood and it's still raining and it's super cloudy, you're not going to get any imagery, right? So you need to change your date. So right now you can't choose the data set. Again, like I said, we have access to anything with this structure that we've created. We have access to anything in Earth Engine. So if there's a product that you are seeing this structure and workflow, you're like, oh, I wish you had the embeddings from Alpha Earth. And that's something we're thinking about. Or I wish you had the air pollution data. Please let me know. It'd be great to get your feedback. And we could start to think about, okay, for version 2. Or if you guys want to collaborate on a custom version that you think could be useful for specific use, we're totally open to that too. So we're just excited to share this and hopefully get people using it. That's the idea.
What happens if you ask for something that doesn't exist, like a tsunami off the coast of Sydney yesterday or something?
A tsunami off. Let's see what it does. The coast of Sydney from yesterday. It should say that it can't do that. We've been spending a lot of time really trying to give it guardrails and making sure. So search the internet. Said there was no tsunami off the coast of Sydney yesterday, according to blah, 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 blah. If you'd like to map real coastal change, storm surge, or flood impacts in Sydney using satellite data, I can assist you with that. So hopefully we were trying to get it to not try to answer things it shouldn't answer. And that's been really tricky to restrict it, but still have it be flexible, right? We want it to be conversational, but we don't want it to say, I can't do that. And well, why not? So we're trying to get it to give you a reason and then say, well, it could do this. So that's a good, interesting question, Nathaniel, just sort of thinking about that. And that's been a real struggle to try to keep it flexible, but not do things it shouldn't do, or try to do things it shouldn't do, or answer questions about things it's not supposed to answer questions about. So we want to make sure we're careful with our liability, and people try to use it for things it's not made for, and they'll get frustrated, And that's another big challenge for us, is to educate folks, right? It's not just a regular chatbot, it's a geospatial AI, and it has its sort of specific functions. So we know that we need to make sure that users are educated about the types of questions. And so that's why we kind of tried to give some examples. We're making some YouTube videos too. So hopefully I can work with Nathaniel and I can send you guys all a follow-up email if it sounds good. And we can share all the videos we've made. We can also, I'll share the soft launch with all of you. so that if you're interested, there'll be a really affordable entry level, less than $100, and then you can play around and see what you think about it, et cetera, et cetera. And then very much, if you want to reach out and discuss potential custom instances or things you'd really like to see, please, I'd love to hear from you. That would be great, because there's nothing else quite like this yet that we've seen. And we're hoping to continue to grow it and make it more useful for folks like you. So.
Fantastic. Thank you so much, Brent.
Yeah, no worries.
Are there any links you want to pop in the chat now? Otherwise, yeah, I'm happy to share them after the fact.
Yeah, I say let's just share them after the fact, and we can pull them all together. Yeah. Well, thank you, everyone. Great questions. Thanks for the interaction. I really appreciate it. And thanks, Nathaniel, for coordinating everybody's time. I really appreciate it.
Good stuff. All right. Thanks, everyone, and see you next time for our Google Developer Group AI for Science events.
All right. Cheers.
Thanks.
Bye.
See you all.